Today we're going to be working backwards using the normal distribution that given a certain percentage, we're going to find the associated values that come with it. Now we've done this before, but this one's going to be unique because we have to worry about what is going to be called the middle percentage. Again, a quick example as to why you want to do this. If you own a retail store, for example, you want to figure out what items or what dollar items make up the top 10% of your sales, for example, or what dollar value items make up the bottom 20% of your sales. Again, something simple to ask, and probably most people think that statistics aren't necessary, yet you can use the normal distribution, given that the population is normally distributed, to figure out these type of things. Let's write that down. Working backwards. To find x values given a middle percentage. And we'll get to that, what it means. And we'll start with an example right away. We'll do one where we're going to thoroughly talk about the example, and the second example will be a lot swifter. Starting with example 1 here. Suppose we have a population mean of $50 and a population standard deviation of $10. Now remember, the money aspect, or the dollar aspect, is simply a unit to attach to the problem. We could be talking about the same retail store, we could be talking about other things, or you can even change the units to something that's more relevant to you. Here comes a question though. Working backwards, determine the values associated with the middle 68%. Values mean the numbers that are part of your data set, in this case the population. Now remember, every time working together, I always encourage people 2 statements. 1, to figure out what the question is being asked of you. Figuring out the question is quite important because then you know what's going on, what you're going to be working towards, and that you don't do any unnecessary extra work, because imagine doing all that work and you find out that doesn't even answer the question. The second thing is to write down everything you know. Even little details here and there, it's important to have them because sometimes they might shed some light in terms of one thing you're forgetting about the problem, 1 or 2 things, maybe even 3. And having it all written down instead of having to flip back and forth to try to figure it out makes it a lot easier. So breaking this problem particularly down, you'll find out that the biggest hint here is this working backwards right here. Then you already know what I've come to describe as a visual cue or a visual acuity of the following. Percentage, that goes to some associated Z-score, that then goes to some associated X value, as I've called. Sometimes you'll see me refer to these as data points because they are basically pieces of data within your population or sample size or whatever the case may be. Others, though, may determine these as cutoffs because they are, again, still values that cut off where the data is supposed to meet. And again, we'll have a picture of that. Sometimes you'll see me call them as markers as well. Like a marker, it marks at one point. And the other key component is the fact that not only are we giving a percentage, we're doing this middle 68%. Now let's draw a picture so we can see what that means. Here's our normal distribution. And your mu of $50 in the middle. Okay. And what happens is that we're going to draw these dotted lines that represent the middle 68%. Now that's rather straightforward, or relatively straightforward. The X values, or data points, or cutoffs, or markers, all those four words I mentioned briefly, are these right here in this light blue color. In other words, we're trying to figure out what this number, x sub 1, x sub 2 are, such that when you're talking about those two numbers, all data within the population between those two make up 68% of the data. Again, remember that's assuming a normal distribution, and then all normal distributions have 100% in terms of percentage for the data. Previously, working with this, I've written down steps. I'll write down the steps again, however, I'll notate some of the aspects that are unique when working with the middle percentage. Step 1 here. Previously, I've described this as determining the percentage you want to work with. Determine the percentage needed. Now, some people might rush into this thinking 68%, whatever the case may be. The problem, though, is that what you'll come also hear me to say a lot is that whenever we're working with the normal distribution, we have to worry about reading the normal distribution table, or the Z table, or the Z chart. And you'll always find me to say that the normal distribution reads from left side of the normal distribution to the right, and I'll draw an arrow notating that. So imagine this is the very end of the distribution, quote unquote, and this is the very end right there. So you're always reading from left to right. Again, this is for the Z tables, reading left to right. So we know that we have 68%, but that starts from the middle, that's not the left. So first step here is to take 100% and subtract 68%. This will give us 32%. Now what is 32%? That represents this area or region outside here. 32% represents this portion as well as this portion. So 68% is in the middle, and then the two outer parts, and this is what I said would be called tails, represent the outer portions. The problem is that we have two tails now, and again our chart reads from left to right. Well, you can't start on the right side, so we have to start on the left side. But we need half of 32, right? Because 32% represents both tails. So to get only one, we have to divide by 2. So this implies that we take 32% and we divide it by 2, or in other words, half. This then gives us the percentage we actually need to work with, which is 16%, or 0.1600. Okay? Now, all of these right here, which I'm going to mark with a pink asterisk, is that this is what's needed when you're working with the middle percentage. And I'll write that again here too. Pink asterisk, needed when middle percent is asked. In our case, this is what we need. The second step, I'm going to scroll, now is that once we determine what percentage is needed, we need to look for this percentage. Look for the closest to the needed percentage. Now remember, if you pause the video and take a moment, you'll look up any normal distribution chart, well, almost any normal distribution chart. I can attach one to this as a hyperlink as well, but basically it's not the numbers on the top or on the far left side. They are the values that are inside the table. In other words, they're the decimal points that have 4 decimal places. In our case, we are looking for 1600. Now I actually looked this up in advance. It turns out the closest one that 1600 gets to within the table, so I'll write here, within Z table, Z table, is 0.1611. So the percentage we needed was 16%. That's apparent because of the 32% right here, and the fact that this is 16% here on the left and 16% here on the right. So that's where 16 comes from. And again, that comes from the division, subtraction from 100 that you can see above right here. Step 2 says that we need to find 16%, or at least the number closest to it. And again, if you pause the video, you can take the time, you can find that it's 0.1611. And then from there, it's kind of built within step 2, but I'll write it as a separate step here. Step 3, find the associated Z-score. And again, I'll write this in purple because that's what I generally do. Once looking inside the Z table at 0.1611, you want to make sure you look to the left first, and that will give you the beginning of your Z-score. But don't forget to look up as well, because then that gives you the hundredths place of your Z-score as well. Again, I've done this ahead in advance as well, and we find out that 0.1611 gives you a Z-score of negative 0.99. Okay, let's scroll back up to our picture right here, just to look really quick. Again, there's 16% here, and we find out that the first Z-score we have is negative 0.99. Now, does this make sense? You have to ask yourself that as a self-check. And it does, for 2 reasons. One, the fact that the Z-score has to be negative because it's on the left side of the population mean. Remember, population mean in normal distribution is always 0 in terms of Z-scores. Here, in this case, since we know that the left marker, x sub 1, is on the left side, our Z-score also better be negative. The other reason to know that this is the right answer is that when you're looking up the table, again, left to right, you know that the 16% is moving from the left to the right. So up until the pink marker, up until the x1, again, not drawn on the scale, that represents 16% of the data. Now what you also should realize is that when you're looking at this, you should come to the conclusion that, well, wait a second, if I have 16% on one side, what about the other 16% on the other side? Well, the thing that you should always remember when working with the normal distribution is that it is equality, or in other words, it's drawn equally. It is equal every single time. So that means that when we're working with 68% from the middle, if you have 16% on the left side, you must have 16% on the right side. adding them all up together gets 100%. Well, if you move from the mean, or in this case, z equals 0, and you move to the x sub 1 and you get negative 0.99, you should realize because of symmetry, on the right side, this is actually also positive 0.99. So this implies that you have and a z-score of positive 0.99. Sometimes you'll see this written this way, z equals plus or minus 0.99. And again, it's because of symmetry that allows you to do that. We have this portion right here that we found from left to right, 16%. Now if you still wanted to stick to the left to right method, you could add 16% to 68%, and then that will give you the marker for x sub 2. But that's so much extra work, right? You can do that if that makes you more comfortable. The bigger picture is to realize the symmetry, but the fact that there's 16% on the right side as well. So whatever it is equal from the middle to x sub 1, it has to be equal from the middle to x sub 2 as well. Again, symmetry. Let's scroll back down. And the last step is, once you find the z-scores, in this case plural for z-scores because you know there's 2, working backwards, and the fact that it's a middle percentage, find the associated x values using a modified z formula. Now I will say this, recall that our z-score formula is the following. Previously I've used algebra to derive the formula. I won't do it this time, but I will write the formula that we need. This implies that we're looking for x z times sigma plus mu. And again, I'll box this here for convenience sake. That's the formula we're going to be using. And remember, we're going to need 2 of these formulas, or in other words, we have to do this twice because we have 2 z-scores. Generally, I like to start with the negative first because that implies the left side, and then we can do the right side afterwards. So x sub 1, again, equals negative 0.99. Now, if it bothers you that we're jumping right into the formula, I would say this is a great time to use 2 things. 1, writing down the formula as I did right now for yourself, instead of flipping through notes and whatnot, and also writing down the variables needed. So on the right side here, I'll write really quick. X sub 1 and x sub 2, that's equal to a question mark, because that's what we're looking for. The z-scores are plus minus 0.99. Mu itself is again 50. Standard deviation, or sigma, is 10 in this case. The last thing I want to mention is that, remember, all of this right here, where we have to worry about 2 sets of z-scores, this also has to do with the asterisk, as I mentioned briefly, that this is unique to when you're working with the middle percentage. Now we can continue the problem. This is multiplied by 10 plus 50. Now whether you use a calculator or you do this by hand, just make sure that you get it right. I actually did this in advance. So this answer here should be 40.9. If you do the same exact thing for x sub 2, now the difference is using the positive version of 0.99. No need to write the plus sign there, but you can if you like. We find that this value again, I did this in advance, is 59.9. If you need, I would pause the video and make sure that you can calculate this properly. Now those are our answers. Let's see how it looks like in our table when we move back up. 40.9, 59.9. So you can see in this bracket right here that I'm going to draw in green, you have to remember that the X values or data points or cutoffs or markers, whatever you would like to describe them, they are equivalent to the Z-scores. Now they may be different numbers, of course, but the important part is the fact that they represent the same point in the normal distribution. They're just called different things. Again, the analogy I've used before is that they are the same exact meaning, just two different languages. Therefore, within the normal distribution, $40.9 or $40.90 and $59.90, that represents every piece of data between those two values, 68% of the data. Yet if you said the same exact thing about the Z-scores, it'd be equivalent as well. You can find 68% the data between a Z-score of negative 0.99 and positive 0.99. Moving on to another example, we're going to use the same exact numbers. This is example 2. Using the same mu, or in other words, population mean and sigma, standard deviation as above. Working backwards, determine the values associated with the middle 95% of the data. Again, this is already familiar with what we've done so far, so now we can move a lot quicker, but without starting with underlining or writing down what we know. Again, this is working backwards, and we have the middle 95%. Drawing a quick picture here. You can draw this, again, a little bit wider, because you know we're asking for more of the data this time. We're looking for an x sub 1 here, and an x sub 2. And this time, you have 95% of the data. So again, following the same steps, right? And we don't have to write step 1, step 2, step 3 out every time. But if it helps you, please do. But the idea is that we have this 95%, but we can't use it because it starts in the middle. Again, the Z table reads from left to right, so we have to subtract. That gives us 5%. Now what does this 5% represent? Remember, it represents this portion and this portion. In other words, the tails of the normal distribution here, 5%. But since we work from left to right, we can only use half of that. So we got to take 5% divided by 2, and that gives us 2.5%, or the better way to think of this, 0.0250. Make sure I did that right. Okay? So that's the percentage we have determined that we want to work with, and we got to look it up now. Well, it turns out that in step 2, as well as 3 and 4, the percentage I found is actually an exact value. This goes to a Z-score of negative 1.96. And now remember, that's technically step 3 right there. But again, I'm doing it a little bit quicker since we have already the beginning or the basis on that previous example. You can also take the opportunity to also write this as a plus sign right here, because remember, we need both the positive and the negative versions of these. And remember, this portion here at the top in step 1 is unique to the fact that you're finding the middle percentage. Again, I'll write those Z-scores right here under the unknown X values. Step 3, or 4 now technically, is using the same formula to figure out both our values. And again, it helps if you write down the variables out. Plus or minus 1.96. Mu is 50. Sigma is 10. Scroll here. And it's exactly as you would imagine. Same thing we did before. We have an x1 now. We're going to take the negative first because that represents the left side. Times the standard deviation plus population mean. Again, I did do this in advance, so I find out this answer is 30.4. Doing this one more time for x sub 2, this time we're using the positive 1.96. Again, I did this answer in advance, and this gives us a 69.6. And those are your two answers right there. And we can write down these answers as well into our graph so that it can make sense visually. 69.6. And there you have it. You have 95% of the data from the middle. Okay, that means we have 5% on the two tails. Well, we can't use 5% because there's a left and a right side, but our z-table only reads from left to right. That's why I divide by 2. That's why we have 2.5%, and that's why we use the decimal version, 0.0250. We look that up inside our table, where there are 4 decimal places. We find the associated z-scores. Once that, we use the formula properly to figure out what those x values represent. Once we find them, then we now know, oh, between 30.4 and 69.6, or in this case the dollars, $30.40 and $69.60, all the data between those two values represent 95% of the data.